So we are now back to the tanker question, which we have seen in the earlier pages. So if you can recall, it comes out here. But for this part, it is focused on the kinematics. So what happened is that now, we are now focusing on the forces part of this question. So like I said earlier, if you look at this, there are two forces acting on it. Firstly, you are given the mass. So usually I will write it down. The mass is 1.5 times 10 to the power of 6 kg. Then it says that there is this force that is moving forward and it is of a constant value. So I know that there will be this force, I call it F, and it has the value of 2.5 times 10 to the power of 5 Newton. And the fact that here it says that the acceleration is not constant is trying to hint to me that there must be an opposing drag force over here. Let's call this drag force. Basically, it's a resistive force. And this particular force is not constant. It is changing. And this particular force, D, will change with speed. So the higher when the speed is high, then the drag force will be high. So this D is not a constant force. And this is the very reason that your acceleration is not constant. Later on, I will be explaining why is this causing the acceleration to be always changing. Okay, so now the question is saying that even though D is changing, at one particular instance, this drag force has this value. So we are talking about with freeze time, and at this particular instance, the drag force is 1.2 times 10 to the power 5, and you are asked to find the acceleration. So whenever we are dealing with forces, we will be relying on two equations. The first equation will be your F net equals to ma. The second equation will be your meaning of F net, which is sum of forces. So I have to just caution you, especially for those who are not so good in forces, F net and F are two different concepts. They are not the same. That's why when you are quoting the formula F net equals to ma, this F net and this F are not the same. Okay, so it is very important for you to recognize that. So let's develop this. Most of the time, I will train my student to combine these two equations right away. So once you combine these two equations, you will end up with the left hand side ma, and then the right hand side sum of forces. So how do we apply this equation? We will develop each side downwards. Okay, then we will develop this downwards. We will develop it, we will expand it first, like that. Okay, so let's do it step by step, and then we'll go through it very slowly, just for those who have forgotten what I have taught you in class. So MA, we already know the M, which is this huge number of 1.5 something. We will substitute the number. This number is your M, right? We will substitute it at the end. And basically what we are interested is to find this acceleration, which is given by this. Now, sum of forces, we are interested in the horizontal dimension. Okay, so the weight and the normal contact force and all those, we don't care, because we are analyzing it in the horizontal dimension, which is given this. Because this acceleration that we are talking about is in the horizontal dimension, right? It is moving the tanker forward and back. It is not up and down. So we don't involve weight and normal contact force here. So if we look at that, right, sum of forces, there are two forces. The first one is F. The second one is your drag force. But the drag force is acting in the opposite direction. So because of that, this drag force will take a negative value, so minus D. So once you see this, you will notice that if your drag force increases with speed, that means that this drag force will start off with 0, because at that point your tanker, it is from rest. So at the very beginning, your drag force actually equals to 0 at time equals to 0. And as time increases, you will notice that the tanker will speed up. Okay, and because it speed up, it means that your drag force will also rise. So this drag force, as it rises, there will be a time whereby the drag force has rise to such a value that is equals to F. Now when D equals to F, right, then this part your right hand side, F minus, if this guy becomes F, takes the value of F, then it will basically equate the right hand side to 0, right? When D equals to F, then what happens is that your F minus D will give you 0, because we are talking about this part, right? F minus D. And when D is equals to F, then this whole expression will become 0. And when that happens, we say that your acceleration will no longer be there, it will be 0, and your speed will basically be terminal velocity. Okay, it will be, your speed will be constant, and we call this particular speed terminal velocity. Okay, we just give it a special name. Yeah, so now let's go back to the question. Now the question is very good. They actually tell you that the drag force is 1.2 times 10 to the power of 5. So now you can put in all your numbers and you can play around. So F will be 2.5 times 10 to the power of 5 minus of your D, which is 1.2 times 10 to the power of 5. You got it from here. And then you will have your M here. You will get 1.5 times 10 to the power of 6 times A. So now if you look at your equation, your A is the only one that is unknown to you, so you can solve for this. Yeah, so I leave it to you to solve it. Okay, now for part B, you have to explain in terms of forces why the acceleration is not constant. And if you have been doing your TYS regularly, you will notice that, doesn't this look very familiar? I have to explain why acceleration is not constant in terms of forces. Let's go back a few questions earlier. And you can see here, we are approaching it here. Can you see this? Explain in terms of forces why acceleration is not constant, right? Because we say that between A and B, you can see that the gradient is not constant. So can you see that this question is being repeated and it is 3 marks? So if you have do enough TYS, you will notice that Cambridge has to recycle your questions because your syllabus is very small. Okay, so basically how do we explain changes in acceleration using force? So let's use this question to recap. First, I need to talk about the object is changing speed. As a result, air resistance changes, but in our case, we do not talk about air resistance, we talk about it in terms of drag force. So the drag force of the object will increase. After that, I give an expression that describes my F net. In this case, it won't be W minus R, it will be the forward force F minus the drag force D. And then I will say that because the drag force is increasing, my F net will be dropping. And then I give my Newton's second law. I say that since my F net is dropping, my M is a constant, my acceleration will be dropping. So again, the format is the same. So let's apply it to here. Yeah, in terms of forces, why the acceleration is not constant? Well, we have to say that, yeah, your speed of the tanker, okay, it is rising. Yeah, and then wait, in this case, be careful, let's look at the context. Did it say? No, okay, the context didn't say that the engine has stopped, but I remember in the original question the engine has stopped. So let's assume that the engine is still running. So we have to say that because the engine is running, your speed will increases, right? So the speed of your tanker will be increasing, and as a result, right, your drag force will increase as your speed increase. Then after that, give them the expression F net in this case will be equals to F minus D, yeah, the forward force minus the drag force, yeah, and because of that, you can say that now your F net would be dropping. And then show to the examiner that you know the governing law, which is your Newton's second law, F net equals to ma. So now since your F net is dropping, m is constant, you can then easily conclude that your acceleration must be dropping. Simple as that. So you can see that the skills in answering your structure question is always repeating. Okay, first you notice that you describe what is happening in the context, how this description will affect it in terms of your drag force. So now this piece of information, drag force increase as speed increase, is not in the question's context. It comes from your content knowledge. So by saying this, you are telling the examiner that, hey, you know, I know my stuff. And then you show it to them that you can do mathematics. You know that, because of that, then my FNet will get affected. You show them that you know the effect on FNet. Then again, you show your content knowledge that, hey, you know, I know Newton's second law. And then you show your understanding to the second law by applying it to the context. So that is how you score in O level. It's like telling a story in terms of what you know, okay, using mathematics. So that's the beauty of your physics.